We learned BGP, a protocol with a lot of attributes rather than metric. So even if I have multiple paths for a particular destination, BGP will eliminate all the paths except one and say this is the best. You may have multiple paths with same bandwidth, same hop count, same delay. BGP doesn't care about your hop count or delay or bandwidth. It will pick one path and say, because of this attribute, because of this behavior of mine, I pick this path. So in another word, what I should say is BGP is not designed to do load balance. So picks one path that meets the policy and provides that in the routing table by eliminating all other paths. This is very important. Single best route. As I said earlier, you may have multiple paths with same bandwidth, same hop count. Those are all not metric of BGP, so no need to worry. BGP will still have only one path that meets the policy. Now, the best path will be submitted to the routing table manager. See, the best path is just given as a recommendation. BGP's best path need not to be the best path for the router. Now, who has to decide whether it is best or not? Not BGP, the routing table manager. BGP recommends it. Hey, I recommend this path. Now, it is the BGP forwarding table that will have all possible paths, and it is BGP forwarding table the one which is used to pick one best path. But to be the best path in the routing table, it is not BGP, it is the routing table manager. So now the routing table manager will evaluate against the methods of routing protocol to reach the network. For example, administrator distance. Actually, it is only administrator distance, always. Now it compares the administrator distance of BGP, the one which gives the route. If the same destination prefix route is given by OSPF, then it compares the administrative distance. The routing table manager will now install the route from the source whose administrative distance is lower. If it is eBGP route and OSPF route, it is going to be eBGP route in the routing table because eBGP is 20. OSPF is 110. But if that becomes an IBGP route and OSPF, it's going to be OSPF route in the routing table, not the IBGP route because it's 200 lowest administrative distance. So the path with the lowest administrative distance, the source with the lowest administrative distance is what going to be honored by the routing table manager. Now, you remember I was talking about a failure called rib failure. If route given by BGP is not considered because of the administrative distance, the routing table manager has taken the OSPF given route and ignored BGP route. In such occasion, the forwarding table means show IP BGP command, which is showing you the BGP forwarding database, will have R, rib failure, R. So the path control is hop by hop. It's not end to end. Kindly understand this terminology. The control of packet forwarding on hop by hop basis, meaning every hop, every router decides EBGP router's decision and ABGP router's decisions are not going to be same. It is hop by hop. The path decision is made. Here you can see like OSPF stub area 27 between router 2 and 7 and area 23 and area 0, area 18. You also have a RIB protocol, RIB routing information protocol running on R1 where we do redistribution from the purple to the OSPF, purple to the green, not so stub area. So every router has got policies. See, stub is a policy, not so stub area, another policy. RIP, redistribution policy. When you redistribute, you may have some metric, seed metric. Every router now needs to decide the best for itself. So the routing protocol job is simply to learn the routes and give the recommendations to routing table manager. That's the job of routing protocol. Routing protocol cannot force, cannot insist the routing table. Routing protocol can only do recommendation. Individual routing protocol have no control over what gets installed into the routing table. See, this revelation was not there for me many years because no one was clearly mentioning this in anywhere in the books or any documents. Routing protocol they teach. No one said that, oh, it doesn't mean that routing table will have the roots of BGP. There is someone else to decide what needs to be there in the routing table. What is that? Routing table manager. So routing protocol has got no control over what gets into the routing table. It's the routing table manager that is going to decide. For example, here, RIP is giving route, OSPF is giving route, EHRP is giving route. Now the routing table manager will install only EHRP route. Why? Check GY. AS number, administrative distance. is 90. Exactly. Not only that, now routing table may recommend a path. Who has to agree with the path? Switching process. Please understand. Even if routing table has got a route, the switching process may not agree with that. So there is another approver here. First, layer 3 approval is done by routing table manager. Routing table manager approves a route. But the ASIC, the application specific integrated circuit, ASIC, the chips, where the data plane is updated, the path information is updated. That also has got switching process, meaning that also has got an algorithm to use. If you have store and forward method, decision will be different from using IPsec. So in short, what I want to say is, because you are running BGP, don't expect BGP's route will be always there as a packet forwarding path, because there are other levels in which it needs to pass. The route needs to pass in order to become path to be used. Routing table needs to approve, switching process need to approve. Only then you will see a path elected. All right, so that's a brief story about the fundamentals, the basics. This understanding I was not having for many years. I was thinking like, oh, routing protocol is the one who is superpower of router. No, routing protocol just provides the recommendation. And it is the switching process from the routing table manager, the one who is going to decide. I'll give you one example to make you understand what I'm trying to say. Let's say you have a router and you got multiple paths to reach 1.1.1.1. When you trace route from here, please understand and answer me this question. This router L shows two route in the routing table. Router L shows two route in the routing table to reach 1.1.1.1. It says you can go via R, you can go via K. It has got two equal cost paths. EAGRP supports equal cost path by default. The routing table shows two paths. But when you trace route, have you seen two paths? When you trace route, it will take only one path. What is trace? It's an ICMP packet. It increases TTL every hop. So it has to go this way and this way also. And then this way and this way also. But it never does like that. Why? Switching process. Even though your routing table may have two paths, the switching process follows Ceph. So whatever is mentioned in the Ceph table is what going to be used. So don't get, I don't know what English word to use, don't get disappointed when the routing table shows two paths, but the packet forwarded always only one via one path. Don't get disappointed. It is because of the switching process algorithm. All right. More about this, if it is necessary, we'll talk later. As of now, one short thing I want to say in this BGP class is BGP may recommend a route after doing iteration against attributes, but not all the time the BGP route will be seen in the routing table. Now, going back to the BGP attribute topic, these attributes need to be known to us in proper sequence. The sequence matters a lot here. We have to know these in order, in sequence. If not, you will not be able to use BGP effectively. You don't need to know this while sleeping. Even in sleep, you don't need to know this. But when you configure BGP, you should know this. So when you configure BGP, take this from Google or from Cisco page or from this video. Keep it next to you and then configure BGP when you're configuring BGP to meet the policy. Sorry. Now, how the route selection decision process takes place. First of all, you need to assume you got multiple paths and then try understanding this attribute. Hmm. So let's say you are in this autonomous system. I'll call it as AS10. Are you all following? Do you have any question? Let's say autonomous system 10 is the place you want to check which path the packets are going to be forwarded. I have two ISP1 here, ISP2 here. Like I got a router called S router. I got a router called L router as an edge router. Internally, I got a router called K router, and then I got a route called M router. So now we have named it. Let's see. A network called 1111 is coming from internet. Both ISPs are giving you route to reach 1.1.1.1. Now router S and L will check whether the next stop is reachable. Now let's say you got a connection like this. Let me take different color. We got an IBGP connection. So as we learn from ISP1 as well as ISP2, but ISP2 is not directly connected to S. It is not directly connected to S. Likewise, for L, ISP1 is not directly connected. As a result, the next hop address will not be a reachable address for those updates given by the IBGP neighbor. So S will decide to go this way because the next hop given by L is not reachable for S. Likewise, L will decide to go via this way. Now next, let's say L advertises to M and for M the next hop is unreachable. Likewise, S advertises to K, for K also next hop is unreachable. So in this case, K and M will not have route. K and M will not have route to reach 1.1.1. S has got two route but only one valid and best, which is ISP1. L has got two route but only ISP2 given route is valid and best. ISP1 given router don't have a reachable next hop. So tie break happens in the next hop. See, this is the 0th attribute. This is the very first point. Considers only the path which has got a valid next hop. Also the AS loop, meaning if same AS is coming, it won't accept. That's how BGP prevents loop. Yeah. Yeah, reachable next hop. That's right. Fine. Now to make it reachable, we went to S and say next up self to K. Also we say next up self to M from L. And now M and L S and K, they're all full meshed. S is full meshed with L, K, M. L is full meshed with M, K, S. So if you take K and M, they learn from two different sources. One from S, that is also an IBGP. Another from L, which is also an IBGP for M. And M now needs to decide whether to go via S or via L. So before going there, let's talk about S now. Yes, after saying next stop on L, I say next stop self. S is learning about 111 from EBGP as well as from IBGP. And in case if there is tie in the first 6, it will prefer EBGP over IBGP, meaning it will go via ISP1, not via ISP2. Because to go via ISP2, there's no EBGP, there's only IBGP. It prefers EBGP path over IBGP. Fine. So going back to our previous scenario, I think I should use some other whiteboard. This is too kacha kacha. That's what my daughter used to say. It's too kacha kacha. Too messy. Right. Let's take simple topology. Simple doesn't mean small. Simple means easy to understand. Each rectangle is one autonomous system. Right. So we got here like some 6 autonomous systems. Let us take one network here on autonomous system 5. 5.5.5.5. And it is used in BGP. We have used the network command to advertise it. We have not redistributed it. We have used the network command. Now that goes to AS40, 20, and now this router B learns from autonomous system 20 saying 5.5.5.5 is 20, 40, 50. That's the AS path. Now C learns about 5.5.5.5, 30, 60, 50.